So my name is Hanneli. I am one of those red dots from South America that you saw at the keynote. I'm from Brazil. I'm from São Paulo. I am working for this Brazilian company called CodeMiner42, and those are the things that I like to do in my free time. If you like Pokemon Go, we can walk around Dublin because I need some Pokemon to complete my Pokédex. So I was at Python Brazil early in October this year, and I gave the keynote, and I was surprised to see Mozilla here at PyCon Ireland as well, because my keynote was about Rust. So I am an organizer of the São Paulo meetup, the São Paulo Rust meetup, and I had the chance to speak at Rust. So if you're interested in Rust, you can check this talk. A quick disclaimer, I'm going to talk about Python here, not about Rust, and I'm going to talk about one project that I completed by 2015. It was like December or something. So feel free to ask me questions. There are lots of things to be improved on this project because it's quite new. It's kind of a baby. We have some adopters, but we have some bugs as well, so contributions are more than welcome. And this project is targeting people that use Neo4j 2 point something. We also cover Neo4j 3.0, but this is mostly for Neo4j at version 2. So this is going to be an agenda of what you're going to see. I'm going to talk a little bit about document-oriented databases and how graph databases can help us with document-oriented databases. More specifically, I'll be talking about MongoDB and Neo4j. I'm also going to talk about how we build this connector, what's the architecture that we are using, and the challenges that we had to face when we are building the project itself. So how many of you have you heard of or are you actually using some NoSQL databases? So lots of you, because this is popular and this is pretty easy to use. And sometimes relational databases, they are not very practical to some use cases. And then we have to adopt any other kind of database. Document-oriented databases, for example, MongoDB, they're really good because they have some flexible data model, which means that you don't need, a very rigid and restrictive model, such as the ones that you have in Oracle or Postgres or something like that. It's pretty easy to get started with Mongo. They have very rich tutorials, and almost any developer can start using it for a project or something like that in a couple of minutes. It's also very intuitive how we represent data, because like JSON, it's a very popular representation model, and most developers can handle it. So Mongo is very good because it's very simple to use, and it is mostly JSON. So lots of applications actually are using MongoDB. How many of you are using MongoDB? I was surprised because I saw MongoDB office just by the side of the hotel, so that's very interesting. They're a large company, they have lots of adopters, and they have an amazing community, and it's mostly open source, so you can contribute to the project. So we can easily model almost anything with Mongo, and that's pretty convenient. So for this talk, let's imagine a data modeling of a conference. And in a conference, what do you have? We have talks, we have what else? Speakers. We have maybe a timetable, we have rooms assigned to each speaker and things like that, okay? So can we picture this data modeling in Mongo? Yes, no, sort of. So for example, we can, it's a little bit small, but you can picture documents where I have sessions, and the session has some properties such as the title, the abstract. We can also picture, I don't know, some tags, some timetables, some rooms, and this is pretty convenient, right? And this makes sense. So we have some problems here when we are trying to extract some information of this document. So for example, imagine some questions like, which talks have a specific topic, let's say databases? How do you make this query in Mongo? If you have something like tags, you can easily fetch a tag from an array and determine if a session is from the database topic or from a general topic, for example. How do you make a query to say, like, which speakers will be talking about a specific topic? So, for example, I am talking about databases. The previous speaker, Brian, was also talking about data. So how can we make this query in Mongo? Can you picture that? It's not that complicated, right? We can, find the tags and also find the speakers and match them and see if we have a certain speaker will be talking about a certain tag. We can make lots of questions about our data, but here is a more difficult query to make. So, assuming that we don't want to change rooms because maybe we have a person with accessibility problems and this person wants to stay at the same room during the entire conference, what is the best room to stay to get a higher number of sessions from a specific topic? So imagine that you have a bunch of rooms, such as this place, and each room has different sessions and with different topics, and how can we say to this person, stay at room, I don't know, Goldsmith 3, because at this room we are going to have much more talks about databases than in the other rooms. How do you make this query in Mongo? Can you picture that from the top of your head? We can make that, but this is not a very intuitive query, and you have to perform lots of extra operations outside Mongo to count and perform and give, and assert the room that the person will be. So this is some sort of complicated query. We can also make some future work, like we can build a recommendation system. This is a data track, so we can talk about machine learning and techniques to recommend topics to people. So we can build a recommendation system for talks, for the speakers. We can build a tool to, build the timetables for us. So sometimes it's convenient to have data in documents, but sometimes they're not intuitive. And sometimes a graph data model can be much more easy to understand and to use. So we can build graphs with the information that we fetch from Mongo. We just saw a good use case, like to determine which room would be the best room for a person with accessibility to stay during the entire conference, covering the largest number of talks given a certain tag. This is good for graph modeling. And that's mostly why we built this tool, to automatically import data from Mongo to Neo4j. And let's see how it works. So basically, we imported data inside MongoDB to Neo4j, which is a graph database. How many of you are familiar with Neo4j? So it's basically a graph database. If you're not familiar with graph database at all, just think of a graph model that actually can persist data. And it's a pure graph. So MongoDB provides us this tool called Mongo Connector. And that's a pretty convenient tool. It's open source, and using this interface, basically, we talk to Mongo using this interface, and Mongo provides us a way to get all the events that we have in Mongo, and it allows us to throw and communicate with any other database. So using this interface called Mongo Connector, we can build connectors to, Elasticsearch, Solr, Redis, and we built this one for Neo4j using the same interface. So this is a little bit how it works. So we need to use Mongo with replica. So we need to start a replica within Mongo. And this replica is going to make this communication between Mongo and our connector. This is pretty simple to use and to expand. The general architecture that we have is like Mongo connector is going to be some sort of bridge between Mongo and Neo4j. So we have this, I'm going to show you the code a little bit. We have the Mongo connector talking to PyTorneo, and both are in Python. And then we can build this bridge between MongoDB and Neo4j. So basically, we have an interface class called Doc Manager, where we implement all the events and commands that we can type in Mongo, such as upsert, bulk upsert, update, remove, search. So everything that we perform in Mongo is going to be replicated in Neo4j as a graph. We currently support Python 2 and 3, but we give preference to Python 3. And the idea here is like, once you start this Mongo connector, basically all your data inside Mongo will be transferred to Neo4j. And every new comment that you run, if you insert a new document in Mongo, will also be automatically replicated to Neo4j. So that's pretty convenient. You have zero cost to actually build your graph data model. If you have an immediate need to have a graph representation, you can easily use this connector, and all your data will be easily imported. So let's talk about how we do the data mapping, because on one side, we have Mongo with documents, and on the other side, we have a graph. So how we actually make this translation between documents and graphs in such a way that it actually makes sense for most of the applications. So to sync the data that we have in Mongo with Neo4j, we had to build it step by step. So in Mongo, we have a collection, let's say talks, for example. And for every collection, we are going to build some sort of root node in Neo4j. And inside each collection in Mongo, we have the document itself, right? Are you familiar with this kind of model? If not, for those of you who are not familiar with Mongo, we have documents represented as JSON. I'm sorry, the layout broke a little bit. I'm not a very good CSS programmer. So imagine that the green tag is actually targeting name. So for every document that we have an information, a root information. So for example, in this case, we have session, we have topics, we have room, we have speaker. And all this information will be translated as a node. So for example, as you can see, we are going to translate this as document session and document speaker. So for every nested JSON that you have, for nested key that you have, we are going to translate them as a node in our graph. And so if you notice, our documents, they have properties, and we are going to translate these properties as node properties. So for example, if we are thinking about a node called session, we are going to have the property title assigned to this node here in the graph. And it's important to understand that we have to connect these nodes from the graph in a certain way. So at Mongo, all this information is connected by the collection, right? So session is an information that you have inside talks collection, for example. And we are going to connect all the nodes from a collection to the root node. So basically, we're going to end up with something like that. So if you have the root document as talks, we are going to connect all the other information within this root node. Otherwise, we would have unconnected nodes, and we would not be able to perform any operation inside this graph. We also support nested documents. So, for example, it's very common that we have a key inside of a key inside of a key inside of a key, because it's a nested document. That's a very common structure in MongoDB, actually. So the way we translate that, so if you see, we have a session. I'm really sorry about this layout. I don't know what's going on. I think it's the resolution. We have session and we have conference. And conference is actually a child node from session, as you can see at this document. So the way we translate that, we actually have, at the very top, we are going to have document talks. And document session is a child of document talks. And documents conference is actually a child from session. So we go raising the node chain following this pattern. We can have as much as node as we have in Mongo. We have to be careful, though, because there is a translation problem. If you have a very long chain inside Neo4j, this can easily make our queries inside the graph much slower, because we are going to have a very deep graph. But the same problem happens in Mongo. If you have too many nested keys, you are going to have problems at Mongo queries as well. We also created a way to translate JSON arrays. In Mongo, it's very common to have a key that has an array with a bunch of other keys. So the way we do that is we have the parent node with session, and for every key inside the array, we are going to create a relationship and then we are going to map every element of the collection. And the problem here is like we had to create a generic way to do this mapping because like inside Mongo we can have an array with any kind of key of inner JSON. So it's kind of complicated to map, and the best way that we found to do this mapping is using an index and go concatenating under different relationships. We also support explicit IDs, so sometimes some people use this modeling, like they make an explicit relationship between documents, and we also translate that. And some people requested a feature like, what should I do if I don't want to map everything that I have in Mongo? Because the first time you start this connector, it's going to import everything that you have into your MongoDB to Neo4j. And sometimes this is not convenient at all. So what you can do, you can create a configuration file. I'm really sorry for the layout. I screwed up something. But you can check, it's online already, so you can check the code and copy and paste it. So you can create a configuration file where you specify the collections that you are willing to map to Neo4j. You can also specify fields or groups of fields that you want to map. You can do that either configuration file, or you can easily use command line. You can use /i to determine the fields that you want to import. It's up to you. Configuration file is kind of better because it keeps your configuration a little bit more organized. So I'd like to reserve the last minutes that I have before opening to questions to talk about the challenges that we had to build this. Data model is a challenge, and mostly because we are trying to fetch data from documents, and we are going to create a generic way to put this data inside a graph. So how can we maximize the happiness of the users? Because each user has a different case for MongoDB, and we were trying to create, some sort of generic tool that could attend and make most users happy. I guess we were able to achieve that. Most users reported only bugs, and the number of feature requests is actually not too high, so I guess users are pretty happy with the results of the imports. Another thing that we had lots of problems is how can we avoid orphan nodes? Because sometimes lots of users, for some reasons, they had collections with a single information, and this information wasn't connected to anything. I don't know if it's a good practice in Mongo. I don't think it is, having collections with a single piece of information. But we saw that sometimes, and that's kind of weird. So we don't know how to resolve that. If you have a good suggestion, let us know. Orphan nodes were also a problem when people were deleting and when people were running set and unset operations. So in Mongo, you can run set and unset. So sometimes we are going to end up with orphan nodes. There's nothing we can do. But the same way we are going to have orphan nodes, we are going to have scattered documents in Mongo. So there isn't much we can do, but we have to take care of it. The other thing that was a real challenge was about how can we perform batching operations, because some people, they had very large collections in Mongo, and Neo4j supports around 10,000 concurrent transactions. So we had to create a batching system that we actually do batch of batches to be able to transfer all the information that I have in Mongo to Neo4j. So Neo4j has some sort of throughput problems. It's very fast for reading, but it's not very fast for writing. And Mongo is kind of fast for writing. So we can write a bunch of data in Mongo. So we had to take extra care here when we are writing in Neo4j. We always have to check if the information or piece of information that we are writing is not bigger than 10,000 nodes at once. We had some weird performance issues, like I don't know, some people, they were using shards in Mongo, and with shards, you were supposed to achieve much more writing results, so we were kind of struggling to make it work properly with Neo4j. I guess we achieved that with Python 3, but we have an open issue for Python 2 because we just can't replicate the amount of information at once. So this is the source code of the project. You're more than welcome to contribute. We have a bunch of issues opened if you're willing to help us or if you have any feature requests. And one of the most interesting things that we learned from this project, I'm going to talk about this in a minute, is that polyglot persistence is actually really good. I mean, this is something that lots of people already knew. It's interesting to mix maybe a relational with non-relational databases, but talking about only non-relational databases, only NoSQL databases, it's also very interesting the chances that you have to mix them up. So for example, Mongo is very convenient to write information from our application, but sometimes we have a bunch of queries that are not convenient to be performed with Mongo. So we can easily have this tool up and running and perform queries in Neo4j. And Neo4j is kind of famous, or became really famous, not only because of it's a graph database, but it's also very useful for fraud detection. And fraud detection is something that lots of companies are interested in. E-commerce companies, I don't know, payment companies, any sort of company is could be interested in fraud detection. And by using a graph model, there's lots of papers that show you what you can do to determine if you have a fraud or not. So for example, at the Brazilian government, we use Neo4j to actually see if the level of corruption of a certain person. So that's very interesting. We have lots of newspapers in the US. They are actually using all their data to find frauds. That's interesting. And with this tool, you can get data that you probably would store in Mongo and find a fraud with Neo4j just by using a connector. It's a single command line, and you're going to have your data imported to Neo4j, and you can actually start performing queries inside of a graph. We have a university from the UK who contacted us, and they asked for some help and some features. So they're a real use case of this tool. The last tool that I would like to talk about is, following this idea of polyglot persistence, I started building another connector, but for Cassandra. So I'm trying to map information from Cassandra to Neo4j, but this is much more challenging, and this is a topic for another session. I actually have this session. It's on mindslides.com account if you're interested. And the source code is on GitHub as well. So that's it. I have 5 extra minutes, and if you have any questions, feel free to ask. And thank you so much for coming to this session. I'm going to leave this slide here. If you're interested in the projects, feel free to check them.
Any questions? Right here, just can't see.
Hello, thanks. Can you hear me?
Yes,
yep.
I can.
Thanks for that really interesting talk. Do you have any experience or thoughts on visualizing the graph data that you have? Are there any lessons learned about what works and what doesn't?
So Neo4j 2, it actually comes with a visualization tool. I don't have time, I can show you the tool, but it comes with a built-in tool that you can actually use, but it's not very good. So there are some third-party tools that you can use. There is a big one near here at the UK. It's called Keylines, and they offer you a very good solution. It's a paid solution, but it's very good. If you're interested into free options, you can use D3. For example, they're very good cases, but you need somebody who can write JavaScript. Or Canvas. Canvas is another good option. If you have a bunch of nodes, like millions of nodes, you can use Canvas. So those are like the free solutions that you can get. If you're moving to a paid solution, you can use Keylines.
Any other questions?
Hey, hello. So you mentioned that in the beginning of your talk that there was some third query that was not very intuitive to perform with Mongo.
Yeah.
So I was expecting you to show us how you will solve that. You will perform that query with this solution, right?
So the way I would perform the solution in Mongo is that I wouldn't try to make the entire query into the database. I would fetch blocks of code. So I would fetch, for example, I would count the amount of tags that I have, and I would create another structure creating some sort of map, external map between the number of tags and speakers containing that tag, and then I would count externally. And the reason I would do that is because probably in the real world case, you'd have separate collections for speakers and for the sessions, right? You probably would have something like that. You'd have separate collections. That's the way I would model. And I wouldn't try to join them inside the database because that would make the database really slow. So that's the way I would resolve. Thinking of purely on that data modeling where everything is inside talks, I'd have to create a counter for tags and create a soup doc in memory while I am performing this to actually count tags and speakers and sort them by the largest number and return that to the user. That's the way I would resolve that.
What about the new solution, the one based on graphs?
Oh, on Neo4j. Okay. So on Neo4j, you can actually you can use a directive in Neo4j called shortest path. And if you have, for example, a node with tags, you can count the shortest path to that node. For example, this is a way to resolve. Or if tags is an array, I'm going to have several nodes connected to a session, for example. And I just can use Neo4j to determine what's the largest number of relationships connected to that node. I can easily do that.
Any other questions?
So the query from the top of my head is select n, nr, and r are the relationships, and then I get where tag is something, and I just sort by descendant, and I got return the first one. That's the query. It's like a single line.
Just a quick question. As you mentioned, like it's really hard to solve the linear chaining problem, like when you have nested like parents and like child and like subchild. It's kind of same in Mongo, but do you have some other alternative solution for linear chaining and like branching problems?
So it's basically a tree-set problem, and we don't have a good way to resolve this. I'm telling you, like because you have the problem in Mongo as well. If you have a too deep chained document, the performance is going to be terrible. And we just transfer this performance problem to a graph, but we keep using the same problem. So one thing that we try to make a little bit better are like JSON arrays, where we actually split them into several relationships, one for each element of the JSON array. And that makes things not so bad as in Mongo, but they are bad. So the good way to resolve this is like you need a good data modeling for Mongo. So for example, instead of having a big collection with nest and nest and nest, create different collections and connect them. If you have this, you're going to end up with several root nodes, and then you can actually connect different root nodes within different relationships. But you need a good modeling in Mongo. I guess I'm running out of time, so if you have any other questions, I'm going to be here today. And thank you so much for coming.